All right, this is FO 2.12, number 10. We're identifying the extrema of the following situation for this function f of x. Just to remind ourselves, extrema refers to the y values of the absolute max and absolute min. Okay, so that definition is pretty important when we're dealing with this problem, because we're not finding the x values, we are finding the y values. Okay, so now if we're trying to find the absolute max and min, just to remind ourselves, the critical places that we need to look for are two places. One, we need to look at the end points of the intervals, mainly this guy and this guy. So 0 and 2 pi are candidates, and then we also need to consider the critical numbers, because relative min and relative max can also potentially be the absolute min and max, but we just have to double check to be sure. Okay, so let's first, since we already know the endpoints, let's now do the critical numbers. So to find the critical numbers, to remind ourselves, we know that critical numbers occur when it's the x values, when the derivative is equal to 0 or does not exist. All right, so let's find the derivative. We know that f of x is equal to x plus 2 sine of x. Okay, so when we take the derivative, we know that derivative x is 1 plus 2 times the derivative sine is cosine x. Very easy. And we know that critical numbers happen when the derivative equals 0. So let's set the derivative equal to 0 and solve for this guy. So how do we solve 1 plus 2 cosine x equals 0? So I want to isolate my cosine x. So what I'm going to do first is I'm going to subtract 1 to both sides to get 2 cosine x is equal to negative 1. Then I'm going to, Then I'm going to divide both sides by 2 to get cosine x is equal to negative 1/2. All right, so now we're all set. So I set it up so that I can find out what are the x values such that cosine of that angle will give me an answer of negative 1/2. To remind ourselves, cosine on a unit circle deals with the x values on the unit circle. So I'm looking for, on the unit circle, what angle is going to give me an x value that turns into negative 1/2. So let's look at all the x values here. Is it that? Is it that? Is it that? Nope, none of them are negative 1/2. But I know this guy and this guy over here. Those two are the only ones on the unit circle that have negative 1/2. So what is the angle that gives me an x value of negative 1/2? The answer is right here, 2 pi over 3 and 4 pi over 3. So the answer to the derivative equaling 0 is that x is going to be equal to 2 pi over 3 and 4 pi over 3. Those are my two critical numbers. Now, I gotta say that that's actually technically not true. There's actually more x values, because we know that the unit circle can rotate over and over and over, right? So we can have 2 pi over 3 plus another 2 pi plus another 2 pi. But we want to check our interval and notice that it says in the interval 0 to 2 pi. So it's only within just one circle. So we are right in saying that 2 pi over 3 and 4 pi over 3 are only two critical numbers in this case. Okay. All right, so we found our critical numbers. Check. And we have our intervals. So let's make a table and put it all together to see which one is our min and max. So here's my x values, and here's my function to see what it looks like. And we know that our end interval is from 0 to 2 pi. So 0, 2 pi, and our in-between are 2 pi over 3 and 4 pi over 3. Let's plug it into our function. Let's just remind ourselves what our function is, by the way. The function is x plus 2 sine x. So let's plug 0 in here. I know it's going to turn to 0 plus 2 sine of 0. And I know the sine of 0 is the y value of 0 degrees. So I know that is the sine of 0 right there, which is 0. So it turns into 0 plus 2 times 0, which is just 0. That's easy. Well, why don't we do 2 pi, because that's basically the same thing, right? 0 degrees and 0 radians is the same thing as 2 pi radians. So we should get, if we plug that in, we get 2 pi when we substitute in for x plus 2 times the sine of 2 pi, which is equal to 2 pi plus 0, and that's just 2 pi. Okay. All right, now let's plug in 2 pi over 3 into here. When we plug 2 pi over 3 in, our sine, which is our y value, is going to be root 3 over 2. So I have 2 pi over 3 plus 2 times root 3 over 2, which is going to give me 2 pi over 3 plus, these cancel out, root 3. Okay, I don't know exactly what that is yet, but maybe we won't have to calculate. All right, next, 4 pi over 3. When I plug that in here, here's my 4 pi over 3, and the y value is negative root 3 over 2. So I have 4 pi over 3 plus 2 times the sine of 4 pi over 3, which is negative root 3 over 2. These cancel out. So I know this is equal to 4 pi over 3 minus root 3. Okay, so it's not super clear which one is the min or max. And so at this point, I might just pull out a calculator and find that the second one is equal to about 3.826. Remember, we want three decimal places. And we know that this third one is equal to 2.457. And 2 pi is 2 times 3.14, which is 6.283. Okay, so of these four values, which one is the min, which one is the max? So we know that 0 is the smallest number, and 6.283 is the largest. Okay, so let's actually write an answer. I'm going to write my answer is that the absolute min is equal to 0, because it's the y value, and the absolute max is going to equal 6.283 or 2 pi. Either work. And that is how you do problem number 10.